The train.csv metadata description you've provided gives a good overview of how the dataset is structured and how the labeling was done by the experts. Given this information, we can understand the following. Each EEG ID corresponds to a full EEG recording session, while EEG sub-ID refers to a specific 50-second long segment within that full session. EEG label offset seconds indicates the start time of the 50-second segment in relation to the full EEG recording. The spectrogram information mirrors the EEG structure, but for a different representation, spectrogram of the data, with spectrogram ID relating to the full session and spectrogram sub-ID to specific 10-minute long segments. Label ID is a unique identifier for the set of labels applied to a given segment. Patient ID is the identifier for the individual from whom the EEG data was recorded. Expert consensus provides a convenient label that represents the consensus of the experts for the brain activity classification in that segment. Regarding the specific brain activity classes, these votes represent how many of the annotators agreed on a particular classification, which can range from seizure activity to different types of periodic or rhythmic discharges or activities. If there is a large number of overlapping windows in the data, it suggests that multiple annotations might exist for the same or very similar segments of data. This could be by design for ensuring reliability and consistency in annotations, but it's also possible that it could lead to some redundancy or conflicts in labels. In terms of data retrieval and display, when you're fetching EEG data for visualization based on this metadata, you'll want to make sure you're querying the correct 50-second segments according to the EEG label offset seconds and displaying the correct annotations alongside them. This is essential for ensuring the visualized data aligns with the expert labels and can be properly interpreted in the context of the research or application you're developing.
Okay, so using the same dataset, it's from Kaggle. There's a link, should be at the bottom of the page. Eventually, this tool will be available for you to play with. You can select your EEG ID, and select the channel. You have a standard, supposed to be a standard EEG montage with one ECG channel. It's most of the time quite noisy. Yeah, not a great ECG, is it? Yeah, I could expect when the ECG looks like that, then there might be something wrong with the data as well. Yeah, looks like baseline EEG, but yeah, it was labeled as AVA. There's only one a 50-second segment. Yeah, ECG essentially missing. EEG is not great. And this was actually labeled as a clinical, what's called general. No. No. There's a lot of rubbish in it. There's DC shifts. I don't know what it is. So the patient ID is being updated correctly. We did double check. Electrode list is being auto-populated, so that's okay. Default is loading this 604 that looks like a seizure. The only problem with it is there's a similar kind of pattern on the ECG electrode, which is highly unusual. And yes, so couple ways to continue from here. There is the spectrogram data that was provided in this dataset. We might generate our own as well, because I don't think they correlate. There's some weird thing there. Let's open the train CSV again. Have a good look at it. Does it fit the screen? Yeah, just. Okay, let's see. I wanna load all these other things. Wanna load the spectrogram ID. So we have all these other labels, and with the actual label, so the idea is when you select by default, when you load the page, there's a EEG ID being pre-selected. You can select a different one, it will show you the whole thing. When you select the sub ID, it will show you just the 50 seconds of that sub ID. Default it will be sub ID 00, because some of those EEG IDs don't have extra sub IDs. You'll have a default electrode selected, and will display the patient ID as well. So the Yeah, this consensus. Yeah, not sure. Let's play it at the top. Label ID. I don't know what label ID is. Let's assume there is some sort of logic to the order in the original file. Just have one form. We have a form ID. Show a comment. Change order and add missing IDs as per the following. See if it can do it. So we have EEG ID, sub ID, spectrogram sub ID. Okay, let's pop this in and just display it in there. We just go JavaScript update based on previous response. Yeah, so this is the column we have in the train CSV file. We have 19, is that correct? We have 15. Right, we also have the chart. Doesn't want to update the JavaScript. Why not? Yeah. I don't have the ability to recall previous responses. That's great, isn't it? Okay, let's start a new one. Update based on the updated HTML file. Theory. So we have this form container. Just do that. No, we don't need a submit button. And you can't modify the prompt. So that's not cool. Okay, let's use GPT-4. We'll need to load it into GPT-4 at some stage anyway, so we might as well do it now. So I want to show a spectrogram in there. Yes, a chart container. Yeah, I want to do spectrogram chart as well. Yeah, I wish there was some sort of just upload onto GPT-4 button. Copilot kind of gave up. I think it will be too hard for it anyway. Let's start a new chat. We have a HTML file that you can see, but it's still missing, well, it's not working at the moment, and it's missing 2 charts. We have a JavaScript, Python code. We have this data utilities, so Python utilities, and the structure of the data is very important. We don't need the info at the moment. I just updated the HTML to include all the columns from the train CSV file. I do need to update the JavaScript and the backend and check that the backend code working correctly as well. Can you update, generate, regenerate the JavaScript code? Yep. We still need the sampling rate and everything. Hey, can you finish generating the JavaScript so we have the whole working code that will execute with no errors? And also generate the Python, regenerate the Python code as well. Yep. Yeah, why is it being lazy? Yeah, it's as if it can't handle that much code or something. Yeah, we have new fields. I'm generating a prompts for GitHub Copilot, are you? You won't be generating the code, would you? And we need the workspace handle so it can actually look at other files. Yeah, it did look at the correct section of the HTML. So we changed the HTML to add this. Yes, simple update. It's applying now. Nice. It's gonna generate the whole code. With no placeholders. No, there are placeholders. You just can't help it. Yeah, we didn't need to refactor the whole code anyway, so essentially starting from scratch. Still doing this. So you have update chat, and then you have fetch and update chat. The names don't make any sense. So we have the, is it dealing with the spectrogram? And no. Okay, it's really broken. Okay, should we go by the errors? Let's clear that. They had no errors. Well, obviously it would be in JavaScript. Script.js line 39. Electrode should have been there. Okay, that obviously was too ambitious. Let's go back to the HTML that we had before. Wait. We will add this spectrogram. Let's copy it. Okay, so back to the working version. Let's test this quickly. Should give a different. Yeah, this is not an input. Yeah, the original idea was to being able to filter based on the label. It's not working at the moment. I mean, these things can be both inputs and outputs, so yeah, the original thing when you do this, should have selected the whole thing. So in this case, 102 seconds. When you select that, it will zoom in on 50 seconds of that specific label. That doesn't work. When loading an EEG ID, we are displaying the whole data in it. When selecting a specific EEG sub ID, we want to display just the 50 seconds window. Can you do this for us? Fetch, oops. Sync function, log fetching, data and updating chart. So we know that's happening, so we can get rid of that log. Let's format. To ensure that only 50 seconds of data are fetched and displayed when the specific EEG sub ID is selected. Okay, this looks too good to be true, so might as well. It promises us to actually do what we want. Might as well just use the whole code. Okay, this one displaying the 200, and this one doesn't work. Do we get any errors? No. Continuing from the previous prompt, what else do I need to change for it to actually work? Meant to be a response. Not only general things, I need specific things. Yes, that one is hard coded. Get the sub ID when selected. It's doing something once, but then it's not doing it again. You have the code, why are you misbehaving? And this happening only once? It's only running on first load. And not every time you select a different sub ID. This was 160. Kinda makes sense. Is this 50 lines? Yeah, this data is so similar. Yeah, spending too much time on this. Let's move on. It does look legit. Yeah, let's assume it's correct. Let's check train CSV file for a sec. Six oh eight. I don't want this to happen. Yeah, we don't really need the decimal points, so the digits after the decimal point. This will be again in JavaScript. On the x-axis labels, can we remove the so many digits after the decimal point? We can just have them as 0 digits after the decimal point. So we have const labels. Is it just one line? Rounding it. Right, this is better. Something wrong. It's meant to be 50, not 100. It's not right. There a chance that the x-axis labels are changing, but the data remains the same? Can you double check? Weird. No, the data is exactly the same. Yeah, there's something wrong with how the data is being retrieved. So the x-axis is being updated correctly depending on the sub ID and the offset in seconds value, but the data is not being retrieved correctly. Can we double check? No. Okay, so we need a spectrogram as well. That's then how this data set works. So kind of making an assumption that the EEG ID is the main thing by which we sort and review the data. It's like the unique, well, I mean, it's that number and this number, and then for it, you will have a corresponding spectrogram ID. There's different Parquet files. One that holds EEG, and the other one has stop this for a sec. We have train EEGs. Then we have the same one. It's the folder name. Train spectrograms. train spectrograms, and one of the files is called this. And that doesn't work. No such file. Let's try it again. I have a typo or something. Doesn't look like. Ah, no, I must have had a typo. So it's 10 rows. That's what I'm loading. Load 20, it doesn't matter. Okay, now what does matter is we have 400 columns. Would that be the frequency? Okay, spectrograms assembled EEG data using method blah blah translates to select specific annotated subset. The column names indicate the frequency. Column names indicate the frequency in hertz and the recording regions of the EEG electrode. Okay. I have a feeling we will have a trouble loading it. Also will load a certain section of it. Let's pop it into the structure. This is the EEG packet, for example, as in raw EEG. And this is the EEG spectrogram. That's exactly right. It's good that Copilot understands the context from somewhere. Sometimes it's playing silly, but it's not that silly, is it? Not silly at all. Can you explain this? And also, I would like to load this data on the front page. So we need to modify JavaScript, HTML, and Python. The final output should be a better version of the following image uploaded. Yes, we're getting EEG, that will be the raw EEG time series, and the get spectrogram, that will be the spectrogram. I need to get the corresponding file. It's obviously not a complete code, is it? Yeah, the read parquet. How do you pronounce this thing? Let's read this quickly.
The image you've uploaded appears to show two types of visual data representations for EEG data: spectrograms on the left side and time series data on the right side. The spectrograms display frequency content over time. The intensity of the colors indicates the strength of the frequencies at a given time point. Warmer colors, like yellow and red, indicate higher intensities. The time series data shows the voltage changes recorded over time at different electrodes placed on the scalp. Here's a basic outline of the steps you'd need to follow to achieve your goal. Python side. You're looking to serve EEG spectrogram data from your Flask application. For this, 1. Read the spectrogram data. You've already got the code that reads the parquet file containing the spectrogram data. This data needs to be served to the front end through an appropriate Flask route. Python at app.route/getSpectrogramData int spectrogram ID. Def get spectrogram data spectrogram ID. Ensure data path points to where the spectrogram parquet files are located. Parquet file equals os.path join path.expand user data path. F spectrogram ID parquet. df equals read parquet file. Convert the data to a format that can be sent to the front end. This may involve transforming the data frame to a dictionary, list, or JSON. You can send timestamps and corresponding frequency bands data. Spectrogram data equals df.toDict orient equals records. Return JSONify spectrogram data. JavaScript and HTML side 2. Modify HTML. Add elements to your HTML to display the spectrogram and time series data. This could be a canvas or a div where you can render the data using JavaScript. 3. Modify JavaScript. Write functions to fetch the spectrogram data from the backend and render it using JavaScript. You could use a library like chart.js or d3.js for rendering the data, or a custom rendering solution if you need more control. JavaScript async function fetch and display spectrogram ID. Try const response equals await fetch / get spectrogram data / spectrogram ID. If response.ok, throw new error. Network response was not okay. Const spectrogram data equals await response.json. Display spectrogram data. Catch error, console.error, error fetching spectrogram data error. Function display spectrogram data, logic to display the spectrogram on the page. This could involve creating a plot using a library or drawing directly onto a canvas element. Example placeholder logic for using a canvas. Const canvas equals document.getElement by ID spectrogram canvas. Const ctx equals canvas.getContext 2D. Loop over the data and draw the spectrogram. This is just a placeholder. Actual implementation would need to process and scale the spectrogram data to fit the canvas. Spectrogram data.forEach frame index. Assuming frame contains frequency data for a specific time frame. Object.entries frame. For each frequency intensity freq index. Map the intensity to a color. Const color equals intensity to color intensity. ctx.fillStyle equals color. Draw a rectangle for this piece of the spectrogram. ctx.fillRect index freq index 1, 1. Function intensity to color intensity. Flash, convert intensity value to a color. Placeholder logic. Actual implementation would need to map intensity to color range. Const intensity ratio equals intensity max intensity. Const color value math.floor 255 intensity ratio. Return RGB 0 color value. 4. CSS styles. Ensure you have the proper styles in your CSS to handle the layout and presentation of the spectrogram and time series data. Final output. The final output should be a page that loads and displays the EEG spectrogram data in a visually appealing and informative manner, improving upon the uploaded image. It will require careful design and consideration of how to best represent the data visually for clarity and utility. It is important to note that creating a complex visual representation of EEG data requires considerable development and might involve iterative improvements. Make sure to test each piece individually and then together to ensure that they work as intended.
Really don't need those as a standalone functions, do they? Don't do much. Literally just one line of code. But if I'll change it now, I'll stuff something else up. We already have that in the HTML. We are using chart.js. Should we have a separate JavaScript file for this? I think it was also assuming Yeah, we need the spectrogram ID. Do we need to show it on the front page? No. Yeah, I just realized all this stuff can probably... Yeah, that obviously will not work anymore because we broke a few things. Don't have spectrogram. Let's call it spectrogram chart. It's called spectrogram canvas. Okay. Still won't work, would it? We're missing a bunch of other things. Like this data utils thing. How many times are we using it? 9 times. It's not really required, is it? Even get rid of it. Get rid of it. Should be able to just do and for PD we need pandas. Get rid of that data utilities file. Don't know why it's even there to begin with. That's right. Is it? Why is it so much shorter? Because it doesn't have that data utils. CSV, that's correct. So we commented that, put another line. It just works. So we don't need that data utils thing. Comment this out. Magic happens. Magic happens. Okay, now we have two versions. Yeah, we don't want to confuse between them. So why when you restructure what's it, format the document, doesn't fix all these little annoying things. Yeah, this one will need more work. If you haven't yet checked out the biocurious.com, please do so. Let me know what you think. There's a lot of interesting tools. Let's start a new chat quickly. Do it just once. Let's go the single shot prompt thingy. Yeah, hopefully we don't need data utils anymore. Yeah, we don't need C. We need read C. We don't need read Parquet. No. Read CSV. And no. Fetch electrode data. And no, so it can go. Data details. Bye bye. We need to focus on the spectrogram bit. We just added it recently. and the code is currently not working at all. Can you help us fix it? Yep.
Absolutely. Let's focus on the spectrogram part. I see a few key points that we should consider. One, root for spectrogram data. The slash get spectrogram data slash int spectrogram ID route is intended to fetch spectrogram data. It reads a Parquet file and sends back the data in a JSON format. The route seems fine, but I'll need more details if there's a specific issue with it. 2. Front-end function for fetching spectrogram data. The fetch and display spectrogram ID function is responsible for fetching spectrogram data and then calling display spectrogram to render it. Ensure that the spectrogram ID is correctly passed and the endpoint responds as expected. 3. Displaying spectrogram on front end. The display spectrogram function is currently a placeholder. To properly display the spectrogram, you'd need to process the data into a format suitable for visualization. Libraries like D3.js or chart.js can be helpful, or you can directly draw on a canvas based on frequency and intensity data. 4. Debugging. If the spectrogram functionality isn't working, check for incorrect spectrogram ID passed to the fetch function, errors in fetching or parsing the response from the server, issues in the data format returned from the server, errors in the rendering logic of display spectrogram. To help you more effectively, could you specify the exact issues you're encountering with the spectrogram functionality? For example, is the problem with fetching the data, processing it, or displaying it on the front end? Any error messages or unexpected behaviors you've noticed would be really helpful for diagnosing the issue.
No, GPT-4 is just being lazy. So whatever it haven't completed, we will pop as a prompt to GitHub Copilot. Yeah, it's actually called the spectrogram canvas. No, I don't have spectrum ID, and why don't you know? That. So the ID is spectrum canvas. What are you talking about? Why keep changing the uh, just do file by file? Spectrogram display. Okay, can we focus on the spectrogram display? It's not currently working correctly. Yes, it's called spectrogram canvas. How it's focusing on the little things, but then it's not actually helping. Where's the rest of the code? Try running it, it won't work, will it? On Earth. It's that click thing. 7 events. 7 events. Change. No, no. Stop doing that. Doing this thing. The EEG chart keeps expanding when clicking somewhere on the screen. We don't want that. The spectrogram is not visible at all. Can we fix the code? Yep.
It sounds like you're encountering two distinct issues: the EEG chart expanding unexpectedly when interacting with the screen, and the spectrogram not being visible. Let's address these one by one. Issue 1: EEG chart expanding unexpectedly. The chart expansion issue might be due to the way Chart.js handles canvas resizing. Chart.js automatically resizes the chart to fit its container, which might be changing size based on user interactions. Here are a few steps to prevent this. 1. Fix canvas size. In your HTML, explicitly set the width and height of the canvas for the EEG chart. This should prevent Chart.js from resizing it. HTML canvas EEG chart width equals 600, height for canvas. 2. Disable responsive option. In your Chart.js configuration, you can set the responsive option to false. This will prevent the chart from resizing to fit its container. JavaScript const chart options equals responsive false, / other options. Issue 2, spectrogram not visible. For the spectrogram display issue, let's ensure that the spectrogram data is being fetched and rendered correctly. 1. Check spectrogram fetching. Ensure that fetch and display spectrogram is being called with the correct spectrogram ID. You might want to add a console log to confirm that the data is being fetched. JavaScript async function fetch and display spectrogram ID. Try console.log fetching spectrogram for ID, spectrogram ID. Rest of the code. 2. Verify data. Log the fetched data to ensure it's in the expected format. JavaScript.then spectrogram data, console.log, fetched spectrogram data, display spectrogram data. 3. Canvas setup. Ensure the canvas for the spectrogram is correctly set up in the HTML with defined dimensions. HTML canvas ID equals spectrogram canvas, width 600. 4. Adjust rendering logic. Confirm that the display spectrogram function accurately reflects the data structure of spectrogram data. If the data format is different than expected, this function may need adjustments. 5. Triggering the function. Confirm where and how fetch and display spectrogram is called. It should be triggered appropriately based on user interactions or initial data load. 6. Check for errors. Make sure any errors during fetching or rendering are caught and logged, so you're aware if something goes wrong. Additional steps. After applying these fixes, test your application to see if the issues are resolved. Check if there are any CSS styles that might be affecting the visibility or size of the canvases. Use browser developer tools to inspect the elements and see if the canvases are rendered but perhaps hidden or overlapped by other elements. By following these steps, you should be able to address the issues with the EEG chart expansion and the invisibility of the spectrogram.
Yeah, where do we get the spectrogram ID? Should be fetched. From the data file. See if it gets the context. It did not get the context. The spectrogram ID not sure about the label. Probably not relevant. But all those are in the train CSV file. Let's see if it gets it now. Yes, it is a placeholder. Sorry, so this is what we currently have. This meant to be the spectrum ID meant to correspond to this EEG. We will need to improve it, make it so we can dynamically select the. So when we change the drop down, it will load the corresponding spectrogram. There's also seem to be something is wrong with the way it's being rendered on this canvas. So we'll try fixing that next time. See you in a bit. Bye.